Hello, 7th grade teachers. I wanted to take a moment to talk about 7.12A. 7.12A is a readiness teak, and it talks about box plots and dot plots. Specifically, it talks about comparing box plots and dot plots, and we'll talk a little bit more about that in a minute. We would expect there to be about 2 or 3 questions over this teak, this SE on the test this year. So you might expect 1 or 2 questions about box plots, and that's what I'm going to talk about in this video, box plots. So all of the secondary math facilitators got together and talked for a few minutes about what vocabulary was really essential for students to understand about box plots, and here's what we came up with. Based on the last several years' worth of released STAR tests, we know that the students need to know the difference between symmetric box plots and asymmetric box plots. When they are comparing box plots, they'll also be asked to compare the range. They might be asked which plot has a larger range or a smaller range. And they could similarly be asked to compare the interquartile ranges. So which plot has a larger interquartile range? They are also likely to see the words minimum and maximum, and of course, the median. So here's a good list of vocabulary to use as a reference as you're planning to introduce box plots to your students. Symmetric, asymmetric, range, interquartile range, minimum, maximum, and median. You can expect all of those terms to be on a question about box plots on the STAR test. They've been there in the past, they'll be there again. Box plots can be kind of abstract, and it can be difficult for students to understand exactly how they represent the spread of the data. So let's look at a really concrete example. 3 really concrete examples, in fact. Here's my phone number, here's my husband's phone number, and here's Tommy Two-Tone's phone number. For those of you who remember the 1980s, it's 8675309. Okay, so we don't know his area code, but I'm going to say that Tommy Two-Tone's area code is 214. So let's put these numbers in order and take a closer look at them. Now, if you look at my phone number, I'm Liz. The first thing you're going to see is that I have a lot of 9s. My husband's phone number is right beneath that, and it has a lot of 0s. Tommy Two-Tone's phone number is kind of cool because it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, now that's proof that his area code must be 214, right? Now, your students are going to see a box and whisker plot right away on the STAR test, most likely, and they're going to be asked to interpret it. But I'm going to go ahead and just analyze some characteristics of my data before I draw my box and whisker plots. It'll make it a little bit easier to interpret those box and whisker plots later. So first of all, my range is 8, and my husband and Tommy Two-Tone are both going to have the same range of 9. Let's take a look at the medians. To find the median, we just average the 2 central numbers together. And all of our medians are different in this case. Let's go find those quartiles. Now that we can see our upper and lower quartile ranges, we can look at some of the data that describes our interquartile range. We'll see this more clearly on the plots in a moment, but just for now, let's take a look at what the spread of those ranges will be. So by looking at the table, I can see that my interquartile range is 5, and so is Tommy Two-Tone's. So we have the same interquartile range. The interquartile range of my husband's phone number is slightly larger. It's going to span 7. We're about to draw a box plot for my phone number, and before I move to a new page, I want you to take another look at that phone number. Look at all of those 9s. It has 5 9s, right? How do you think that is going to affect our box plot? Okay, let's go ahead and draw it. So looking at my phone number, I have 1, 2, 3, 4, 5 9s. 9 is the maximum value, and 9 is also the value of the upper quartile. That's why there isn't a whisker to the right of 9. A similar thing is going to happen with my husband's phone number, because notice that 0 is his minimum value, and 0 is also the value of his lower quartile. So we should not expect to see a whisker on the left of my husband's plot. Anytime that you construct a box plot, you need to start out with an evenly spaced number line. So I need 3 number lines here that are spaced from 0 to 9. The median of my phone number was 7.5, so I'll go ahead and draw that in. Now, my upper quartile was 9, and my lower quartile was 4. So this is my inner quartile range. That's where my box is going to be. Now, I need to shade to the left to represent the minimum of my phone number. The lowest number in my phone number is 1. And this is what my box plot looks like. So one thing I want you to notice is that my box plot is missing a whisker. It does not have a whisker to the right of 9. That's because 9 is both my third and my fourth quartile. It's both the maximum and the upper quartile. I'll go back to my data. Let's go ahead and draw a box plot for Greg's phone number. His median was at 2.5, his lower quartile was at 0, and his upper quartile was at 7. So he has a much larger interquartile range than I do. He has a larger box, and his phone number includes a 9. The highest value is 9. So this is what his is going to look like. Finally, let's draw Tommy Two Tones. Remember that he had each number exactly once. His median was 4.5. His lower quartile was at 2, and his upper quartile was at 7. So his interquartile range is actually the same as my phone number. His maximum value is 9, and his minimum value is 0. One helpful thing to do for your students to show them exactly how the box plot represents their data might just be to draw the data points on the box plot where they go so that they can see duplicate values. For example, let's just do my phone number. My number is 4, 6, 9, 9, 9, 9, 4, 3, 9, 1. So you can see, even though the whisker of my plot goes across 2, I don't have a 2 in my phone number. I don't have a 5 in my phone number or a 7 or an 8. However, those are all included in the range of my box plot. And my 9 has 1, 2, 3, 4, 5 dots on it. It's because I have 5 9s in my phone number. I have 2 data points at 4, 1 at 1, 1 at 3, and 1 at 6. I'm not going to do this for all 3 of the phone numbers, but it can be a helpful way to illustrate data distributions and box plots for your students, just to show them where those points occur. So we've compared the ranges of our data. We said that my interquartile range is the same as Tommy Two Tones, and that Greg's phone number has the largest interquartile range. Greg and Tommy Two Tone both have a range of 9. 9 minus 0 is 9, while the range of my data, 9 minus 1, is 8. I have a slightly smaller range. We can also compare medians. My phone number has a median of 7.5. That gives me the largest median. My husband's is the smallest median at 2.5. And Tommy Two Tones' median is 4.5. So which plots are symmetric? Only Tommy Two Tones. For now, this is all that your students have to do to describe the symmetry of the graph. Later on, when they get into statistics, they're going to use words like skewed and not skewed. Looking at these graphs, Greg's phone number is skewed to the right, and my phone number is skewed left. Tommy Two Tones' phone number is not skewed. So your students don't need to know about skewed data yet. This just gives you a preview of where they're going in upper level courses. I'll give you a quick chart that you can use to remember skewness and symmetry of data really quick. This is more like the type of graphs that you expect to see in a statistics class. You probably remember that the middle one is the normal distribution. Let's say that the blue lines that I just drew represent the medians of these sets of data. When data is skewed to the right, the mean is greater than the median. When data is skewed to the left, the mean is less than the median. And when the data is not skewed at all, the mean is equal to the median. That's the formal definition of skewness. Here's how it looks for box plots. It helps to remember that the long tail of the data points to the right when it's skewed right, and similarly, the long portion of the box plot is on the right when the data is skewed to the right. Vice versa for when data is skewed to the left. Now remember, your students don't need to know about skewness yet. All they need to know right now is whether it's symmetric or asymmetric. This just shows you where they're going over the next several years as they go up into upper level math courses. This is what you're getting them ready for. The last thing that I want to show you today is how to look at all three of these graphs, all three of these plots at the same time on the TI Inspires. So let's create a spreadsheet and go ahead and enter our phone number data into it. I'm going to do my phone number first. This can actually be a really great activity to do with your students too. Just be sure you're using fake phone numbers. 469 999 4391. Okay, there's my phone number. By the way, when you're doing box plots on the Inspires, it is less confusing if you do not use X and Y as your variable names. You'll see Y in a little bit, but if you use X and Y, the students will confuse those variable names with the X and Y axis. In this case, we're going to be plotting all three variables on the X axis, and you don't want them to get confused, so it's easier if they use a different name for their variables. Here's Greg. Whoops. 71392704000. And then Tommy Two-Tone, I'm just going to call him TTT. And his number is 0, well, let me do it 2, 1, 4 in this order. 8, 6, 7, 5, 3, 0, 9. Okay, so we have all of our data in here. The next thing we want to do is add a page. So Control Doc will let you add a page, and we want it to be a data and statistics page. You're just going to have a bunch of numbers plotted for right now. What you want to do to make sense of this is go down to your x-axis and click to add a variable. I'm going to add my husband Greg first. And then I want to go to Menu, Plot Type, and choose Box Plot. There's my husband's box plot. Now I want to have 3 plots that I can compare on one screen. So I'm going to go down here again. Whoops, excuse me. Well, actually over to Menu, and then to Plot Properties. Now, careful, don't add a Y variable. These are all independent variables. I want to add an X variable again. This time, though, I'm going to add my phone number as the X variable. So now I can compare my plot to my husband's plot. Let's do it one more time. So I'll go over to Menu, and then I want to look at Plot Properties and add an X variable. This time I'm going to add Tommy Two-Tone. There he is. And so it's really easy this way to compare 3 different box plots. You can also very quickly change this data and see how that affects your plots. And you can even, if you want to, move around different parts of the plot, and that'll change your data. So it's very easy for students to manipulate these and compare.